This is a Cooler MasterKeys Pro L, and it needs fixing. This isn't the first keyboard that I've fixed, but I figured that this was a good opportunity to show you what sort of tools you might need and how you can repair your own mechanical keyboard. While I will be fixing the specific things that are wrong with this one, I'll also talk you through some of the other major things that can go wrong and then how to fix those too. So let's start with what's wrong with this. It's actually fairly benign, it's just that the LEDs on actually quite a few of the keys are either dying or are outright dead. Some of them are showing similar colors to what they should be, but clearly one of the three actual sub-LEDs that are in these little chips has died and therefore the color match is wrong, but some of them, like S and D, are just outright dead. So we need to replace, well, all of the broken ones, including the partially broken ones too. This is a pretty easy job, and actually repairing almost anything in a mechanical keyboard is relatively easy too, although this is coming from someone who has plenty of experience doing soldering and electronics repair, so let's just show you what's wrong with this board and how to fix it. Now, I need to start by getting this thing open, which turns out is relatively easy, and I also need to change the camera so that you can see this more clearly, because who cares about my face? You should care more about what I'm going to be doing. So let me move the camera around and then we'll get started. Right, with my trusty iFixit kit in hand, apparently there is only one screw that holds this keyboard together, and there it is. So I've got a list of all of the keys that have broken LEDs, and so the first thing to do is to identify which ones those are, because from the back, it's kind of hard to see. But first, I thought I would talk you through the anatomy of the keyboard so that you know what's going on here and what part you might need to actually fix. So if we zoom in on one of the actual switches here, so we have the LED and we have the actual switch itself. I wish this would stay focused. So these are soldered in switches. So you will have to, if one of your switches is malfunctioning, you have to desolder this pin and this pin to remove this key switch. A lot of, especially newer and higher end keyboards in particular, actually have a little socket back here so that they are hot swappable. If you have a hot swappable switch, then all you need to do is pop your keycap off, and then there's normally two little tabs on the side. You normally get a tool with your keyboard and you just pull this off. If you wanted to replace this switch though, you would have to undo this board and then come and desolder these two pins so that the switch would come out. Now sometimes the switch itself isn't actually the thing that is faulty, it's just the solder connection. And I've repaired a couple of those before where, especially from the factory, these are what's called wave soldered. So they will be immersed in solder to just have this, you know, be soldered rather than someone sitting and hand soldering each one. Which means that sometimes they can miss, and sometimes they do work just enough, but especially over years, and as you're pushing on the switch as well, it can break the connection, and then you need to add just a tiny bit more solder to one of those two pins, as an example. This bit here is the main microcontroller. This is what turns all of these key inputs into USB data for your keyboard or your computer to actually register as a key press. Now, if this itself is faulty, you're gonna have a hard time, especially with a board like this that doesn't use an open source firmware like QMK. Being able to try and reflash this firmware and even just replace this chip is going to be a pain. Quite a, what you might call an advanced job. And then you also have what are often either multiplexers or just switches or sub microcontrollers depending on the board. And again, a lot of their little capacitors and resistors alongside them. And then of course we have what we are here for, the LEDs. Now these are little RGB LEDs. Sometimes they're digital, sometimes they are analog. In this case, they're actually pinned out. So we have positive, blue, green, and red pins. So these are analog. So this just takes in some voltage, positive voltage at the top, and then the microcontroller or one of these switches or multiplexers will basically turn on and off the blue, green, and red, sort of short to ground basically, to be able to control each of those LEDs. Now in our case, many of these are faulty, so let's identify them and then get them replaced. I figure while we're here and I'm double checking my my diagnostic work, let me look through all of the possible options again, just to make sure that I haven't missed any. And doesn't seem to go off. And is also flickering. So this flickering that's happening could be due to the LED itself, or it could be due to the controller. We won't know until we replace it, but I'll give it a go anyway. Okay. I'm reasonably happy that the ones that I've picked out are all the ones that are broken, so I'm going to disconnect it and mark out the last couple, and then we'll get to actually fixing it. So of course we need some replacement parts. Luckily, the owner of this board has provided a nice healthy amount of them, so we're good there. And of course we need to talk about the tools and supplies that you'll need. For this sort of repair, if you were just needing to repair one of the switches themselves, then you probably only need a regular soldering iron. My one is a Tilswall. It was like £35 on Amazon and has been rock solid for a number of years, including technically sort of production work for the tools. So I highly recommend that one. I'll leave a link to it in the description. And yeah, that's all you'll need, as well as obviously some solder and one of these. This is a sort of desoldering pump. You push it down, and then once the tip is nice and warm and sort of the solder is ready to flow, you put this on and you press the button and it sucks up all of the solder. Sort of little vacuum pump. You can get proper desoldering stations, but those are a lot more expensive and arguably more niche than just a soldering iron and a cheap little desoldering pump. And this generally works fine. Sometimes you need a couple of goes. And the other thing that you'll need is some flux. Now I have this little tub. I actually wouldn't recommend getting this tub. This is sort of a volume thing, but I would recommend getting it in a more sort of gel and in a syringe, as that's much easier to apply than this more sort of paste type stuff that's in a tub. But you will still need some flux. This helps to keep the solder joints from oxidizing and also helps to dissipate some of the heat around the area. And that's kind of it. Now, if you're going to be doing what I'm doing here, which is desoldering these LEDs, because they have pins on both sides, it's going to be very difficult for you to heat them up with just a regular soldering iron on both sides. You can do it, and if you're only doing one LED or something like that, then a regular soldering iron, especially if you already have one, will be fine. But if you're doing multiple like I am, you'll probably want a hot air station. This 858D is one of the most ubiquitous options. It's one of the cheapest at like 20 quid, and in my experience has worked really well. So definitely a recommendation there. The other thing that you might actually want, especially if you're using the hot air station, is this. This is Kapton tape. It's basically both electrically and thermally insulating, which means if, let's say you wanted to desolder this LED here, it's right next to this plastic connector, and while the plastic connector is probably rated for the sorts of temperatures that you need to desolder this LED, it's probably a good idea to keep it relatively safe. So what you would do is put a bit of Kapton tape over this connector so that it doesn't get burned when you're desoldering the LED that's right next to it. Lucky for us though, all of the LEDs that we need to desolder are pretty free and clear from any other obstructions, so we're just gonna get to heating them up. The first job though is to get a bit of flux on it, and like I said, this sort of paste type one isn't as ideal as the more sort of gel pen type ones, but with a little, I think Americans call them Q-tips, cotton buds, we'll get these all nicely fluxed up. Right, it's not pretty, but it's done. And before we start actually heating things up, I should mention that flux in particular is pretty nasty for your lungs and for your health in general, so you should wear a mask while doing this. I have a full face mask that I use while I'm soldering lots, and I would highly recommend a proper filtered one, especially if you're going to be doing this a lot. Either way, you should have some amount of PPE here, and also just with heating things up, I have burned myself countless times, especially on my hands, so it's going to happen, but be as vigilant as you can when soldering, because, well, the burns from these things really hurt. Trust me, that's hard-won advice. Right, slight change of plans. Turns out that the LEDs that we bought for this repair are actually SK6812s. These are digital, and unfortunately, because this board is like 7 or 8 years old, these LEDs are analog. They are just power in and then selected ground through these multiplexers. Luckily, I happen to have another Cooler Master MasterKeys Pro that I can yoink some of the LEDs from while we wait for some new ones, so let me start swapping these out. I have all 18 that I need, and I'm gonna actually swap the board or flip the board around so that the little plastic dimple from the bottom of the mechanical key switch is facing away so that I can just grab the LED from this side and solder. I'm also using the soldering iron rather than the hot air station, primarily because the soldering iron actually works a lot better. Because the contacts are so small and there's only 4 of them in total and there's really not that much solder here, it's actually pretty easy to pull these off and put them back on. So let's get started. Right, so that is the first one up, so let me stick a new one back down. Although first, there is actually a bit of fluff under the key, so I'm gonna pull that out. And that's the new one soldered in. It really is that simple. Now I just need to do it 18 more times. Right, I do believe that is all of the LEDs that needed replacing have been replaced. I'm gonna plug the back in so I can plug the USB cable back in, flip it over, and see if all of our replacement LEDs are working. Okay, they're all working. Let me turn the lights off and you can see for yourself. There we go. Are they all good? They all look alright. It is still flickering on numlock, so I'm guessing that that's the channel rather than the like the LED itself. That still works. Okay. Well, I think that's about as good as it's going to get, considering that this is, well, of how old a keyboard this is. So let me put this back together properly, and then we can close it out. So that is how to repair your mechanical keyboard. Like I said, it's easier than you might think, and the tools themselves generally aren't that expensive either. And also, once you have tools like this, it also opens up a whole world of possibilities for making your own electronics, making your own stuff, or even just fixing other stuff as well. So they're really handy tools to have, at least for someone like me anyway. If you've enjoyed this video, please do let me know in the comments, hit the subscribe button, turn on the bell notification icon, and check out plenty of other videos on the end cards as well. There's also my own hardware, the open source response time tool and open source latency testing tool, so feel free to take a look at those with the link in the description, osrtt.com. And yeah, otherwise, thanks for watching, hope you enjoyed it, and we'll see you all in the next video.